Alright, today we're going to be going over vector algebra. So a vector, let's say vector A, it's made up of an x component and a y component. And what we're going to do is essentially take those x and y components and add them to other x and y components of other vectors like b, c, and then get a vector such as d that would be the sum of multiple vectors. Alright, so let's take a look at number 10. So number 10 is draw each of the following vectors, label an angle that specifies the vector's direction and the vector's magnitude. So let's start with A. So we have vector capital A that goes 3 to the right, 3 x components. So we would just draw 3 there, and that's denoted by the I right here. And then it goes 7 up, because it's positive 7, and then the J denoting the y components of 7 up. And that means that the magnitude would be connected by basically the end of the first or start of the first vector to the end of the second. So this is going to be our vector A. And so we want to find the direction and the magnitude of it. So let's set this as theta. That would give us our direction, but let's find the magnitude of it first. So we know a squared plus b squared is equal to c squared. So we will just use that. So a squared is going to be 3 squared, b squared is going to be 7 squared, and that's going to be 9 plus 49, which is equal to 58, and we would just square root that. 58 would be equal to c squared, or the unsquare root of it. So the magnitude of a is equal to square root of 58, and also the direction of it is going to be, so this is theta, this is going to be what's going to give us a direction of it. So we know the opposite of theta and the adjacent of theta. So what trig function really works with the opposite over adjacent or adjacent over opposite? So if you remember from calculus trigonometry, it's tangent. So in order to find, if you want to find like opposite over adjacent in tan, you would put tan theta into your calculator. But in this situation here, we're looking for theta. So we're going to put tan -1 into our calculator, arctan, and we're going to put arctan 7 over 3. And that would give us theta. So theta, if you plug that into a calculator, you're going to get theta is equal to 66.8 degrees. And so we could say 66.8 north of x-axis. And that is the direction of vector A, and then the magnitude of vector A is going to be 58, radical 58. And now let's look at lowercase a, or rather acceleration. So this acceleration vector, the two components we're given is -2 for the x component and 4.5 for the y component. So let's draw -2. -2 would be to the left. That is going to be -2. And then the y component is going to be 4.5 up. So 4.5. And now we just connect the two vectors, in which this is going to be our a vector. So a vector is pointing left and up. Let's now find the base of the hypotenuse, which is going to be the magnitude of vector A, which is going to be -2 squared plus 4.5 squared is equal to c squared. And if you do the math, you're going to have c2 is equal to 24.25. And that means that vector A is going to have a magnitude of square root of 24.525. And a lot of times you don't really have to simplify this. Now let's find the direction of it. So again, we know the opposite of theta. Theta is going to be right here. So we know the opposite and the adjacent of theta. So again, let's use arctan. So we're going to have tan -1, 4.5 over -2. And if you plug that in, that gives you an answer of, or rather a degree of negative 66 degrees. But since the negative denoting that it's on the left side of the y-axis, so we could just put that as positive for now. So that means theta is equal to 66 degrees. And we can show that in word form. The reason why we took out the negative sign is because we're going to show it in word form. So vector acceleration is 66 degrees above the negative x-axis. And since we wrote down the negative x-axis, we're not having to put the negative 66 anymore. And that would be your direction. And now let's take a look at vector velocity or vector v. So vector v we have is going to have an x component of 14 and negative 11. Or no, negative 11 being the y component. So we have 14 going this way, and then negative 11 going down here. So this would be 14i and negative 11. Now we connect the vector in which this is going to be our velocity vector. And now let's first find out the hypotenuse of it, or the magnitude of the velocity vector. So it would be 14 squared plus negative 11 squared is equal to c squared. And if you do the math, you would have 14 squared, which is equal to 196, plus 121. So c squared would be equal to 317, and c would be equal to square root of 317, which is also the magnitude of the velocity vector. So square root of 317. And now let's find the direction. So again, this angle being theta here, we know the opposite. The opposite is going to be negative 11. The adjacent is going to be 14. So in our calculator, we would put arctan negative 11 over 14. And if you do that, you would get 38.2 degrees, or you could round to 38. So it would be 38.2 degrees, which means that it would be negative 38.2 degrees, but negative meaning that it's under the x-axis, it's in the negative y values. But we're gonna explain that through words. So if we write it out here, our direction, it's gonna be 38.2 degrees under the positive x-axis. And under the positive meaning that our y value is negative, and the positive x-axis meaning that we're on the right side of the y-axis. So basically we don't have to put negative 38.2 in there anymore. And so those are A, B, and C. Let's try D, which is going to be vector R. Let's take out all of this. So let's go to vector R. Vector R is going to be that our x component is negative 2.2, y component is negative 3.3. So let's start right here. Negative 2.2 is going to be this way. Negative 2.2, and then negative 3.3 is going to be down. Negative 3.3, and then we have our vector R by connecting them. So now we want to first find our hypotenuse. So we're going to have negative 2.2 squared plus negative 3.3 squared is equal to c squared. And if you do that on a calculator, you're going to get c squared is equal to 15.73, which means vector r has a magnitude of square root of 15.73. And now let's figure out the direction. So this here is going to be theta right here, this angle. And how you figure out theta is theta has to be adjacent with the x component vector and also adjacent with the hypotenuse. And you want to have your y value as your opposite, at least in this scenario of vectors. But so for the direction, we're going to use our tan again. So it's going to be tan -1 of -3.3 over -2.2, in which that turns into positive. So if you plug it into a calculator, it would give you a degrees of 56.3 degrees, which means that if we write it out now, it's going to be 56.3 degrees below the negative x-axis. And below meaning that the y value is negative, and negative x-axis meaning the x component is also negative. So that is going to be your r vector. Alright, so let's move on to number 17. So we have let e equals x component of 2 and a y component of 3 plus 3, and then f vector equal to x component minus 2y component. Find the magnitude of e and f. We'll do that first. So e and f, we're just going to find the hypotenuse, basically. We're going to draw triangles here. So our e vector is going to be an x component of 2 and then a y component of positive 3. So 3 and then 2. And that means our e vector will be that if we connect it. And now the magnitude of our e vector is going to be 2 squared plus 3 squared equals c squared, in which that's going to be 4 plus 9, which is going to be c squared is going to be equal to 13. So c is going to be equal to square root of 13, which is also equal to the magnitude of the e vector. And now let's find the magnitude of the f vector. So we have f right here. It's going to be to the right 2 units and then down 2 units. And if we connect it, it's going to look something like that. And now if we find the hypotenuse for that, or the magnitude of the f vector, it's going to be 2 squared plus 2 squared, or negative 2 squared, which is positive 4, is equal to c squared. If we add that together, we get c squared is equal to 8. And then the f vector magnitude is equal to square root of 8. In which you could also simplify that to being 2 square root 2, because square root of 8 is square root of 4 times square root of 2, and square root of 4 is 2. So 2 square root 2 is going to be our f vector magnitude. And now we want to find e plus f. So if you remember from the original slide of vector algebra, e plus f is going to be all the x components added to all the y components. So let's write down vector e right here. So vector e has 2i as our x component, and then 3j. And then let's write down the f component. It's going to be 2i and negative 2j. And all we need to do is add them together. So I kind of wrote it out like this is a really good way to write it out. So we add all them together, we get 4i, and then 3 minus 2 is going to be 1j as our y component. And that's going to be, we could just call it vector g. So yeah, we just write down now we need to find the magnitude of it. So 4i plus 1g, if we write it out now, that would be magnitude of vector g. So we have 4 as the x component, and then positive 1 as the y component. If we connect it, it's going to look something like that. That would be vector g. If we find the magnitude of that, that would be 1 squared plus 4 squared is equal to c squared, in which c squared is going to be equal to 17. And c is equal to square root of 17, which is also equal to um, vector e plus vector f. And that would be your answer there. And then let's look at c. c is negative e minus negative 2f. So what we need to do here is make some changes to the x components before we, I guess, add them together. So first, let's kind of isolate this. So it would be negative 2f and then negative e. And those two components are going to be added together. So we have vector e right here. We're going to put a negative sign on the outside. So it's going to be negative 2i plus 3j. We're going to put parentheses out there, and we're going to start distributing. Let's first put the coefficients where they need to be. And vector f. Vector f is multiplied by negative 2. So we're going to put a negative 2 in the outside, and then vector f, which is going to be 2x component minus 2y component. And now let's start multiplying it out. So when we multiply it out, we're going to get a new vector e of negative 2i minus 3j, and then new f component of negative 4i plus 4j. And now we add this together. So we add this together, not subtract it, but so we add together negative 2, negative 4. That's going to give us negative 6 as our x component of, let's say this is vector h. And then negative 3 plus 4 is going to be just plus 1j as our y component. So vector h is going to be negative 6 and plus 1. And now let's find the magnitude of it. So let's draw vector h right here. So we have 6 units to the left, being that. And then we have 1 unit up. And now let's connect the vectors. So vector h would look something like that. Now to find the magnitude, we find basically the hypotenuse again. So this is negative 6. So it would be negative 6 squared plus 1 squared is equal to c squared. And that gives us an answer of c squared of 37. So I mean c is equal to radical 37, in which the magnitude of vector h is equal to square root of 37, or rather, it's also equal to negative e minus 2f, and the vectors of them. So that is going to be our answer, negative 30, or no, square root of 37. Alright, so for number 18, we have for 3 vectors shown, vector a plus vector v plus vector c equals 1 unit of the y component. What is vector b? So we're going to answer these after we figure out what is vector b, and rather the components of it. So let's write down what we know of vector a and vector c. So let's write it down the same way I did write it down in the previous question. So for vector a, we have an x component of 3i, and then we have a y component of 0 because it's on the x-axis, or that would be a j. And then for vector c, we have an x component of 0, and then we have a y component of negative 4. And for vector b is what we don't know, but we do know the x component is negative, so we can write negative right here, and then we know the y component is positive, so we can just add a plus. And now we want all of this, when we add it together, we want it to equal 1 y component and 0 for the x component. So we just want to fill these in, basically addition, filling it in what numbers could make these equal 0 and 1. So vector a plus vector c, the x components, if you add it together, equals 3. If you make vector b have an x component of negative 3, it would cancel out the original x components. So negative 3i would work because then you would get 0 as an x component, and which is basically what we want. And now for the y component, we want that to equal 1. So vector a and c, they both have a y component adding up to negative 4, which means that for vector b, we want something that's going to that's going to add to negative 4 and then give us 1, which would be 5, because 5 minus 4 is going to be 1. So our y component is going to be 5j. And now we got to write b in component form. So we could do that real quick right here. So b in component form, or actually right here, b in component form is going to be equal to negative 3i plus 5j. And then write b as a magnitude and a direction. So as a magnitude, we know we're just gonna again find the hypotenuse, but let's draw a little triangle here. So it looks something like this. Our opposite would be 5j, and our adjacent would be negative 3i, and this would be theta. First, we're gonna figure out the b vector magnitude, which is gonna be the length of the hypotenuse. So it's gonna be negative 3 squared plus 5 squared is equal to c squared, in which we have 9 plus 25, which is going to be 34, is equal to c squared. So c is equal to square root of 34, which is also equal to the vector b. And now we want to find the direction of vector b. So again, we're working with an opposite unit here and then an adjacent unit in terms of theta. So what we can do again is put into a calculator arctan, or tan to negative 1, 5 over negative 3. And if you do that, you would get that theta is equal to 59 degrees. And if you write it out in word form, and it would be actually negative 59 degrees, but we're going to write it out in word form so we can denote the negative. So it would be 59 degrees over the negative x-axis. And over meaning that the y value is positive, and then negative x-axis meaning that the x value is negative, which makes sense with what we got in our component form.